Hello, my name is Eric Wade, MLTI ambassador, and this PD is about engaging students through math and science simulations. So even if you're not a math and science teacher, if you work with students in other content specialties, then this can still apply. One of the things we're going to talk a little bit about is RTI. So just because it says math and science on it doesn't necessarily mean that this is only for math and science teachers. Please feel free to check it out and watch through. You might find something interesting that applies to your content. There's lots of kind of social studies simulations that are really fun to play with too, that you might find useful. So let's get started. So we'll start with what a simulation is, and we'll look at how do they improve learning. We'll look at how you integrate them, and then a list of resources that might be useful for you to get started. It's quite an extensive list of things that you can use here. So let's start with what is a simulation. So a simulation, basically, and you can read that yourself, but basically the idea is it is a way for students to manipulate a variable inside of a computer program or an application that then gives them data that they can use to to back up a claim, or to learn something new, or perhaps explore something new that they may not have experience with prior to whenever you're doing it now. The other thing about simulations that I really find are useful, and I'm going to kind of use the simulation model as simulations and models kind of interchangeably here, even though they are very different from each other from time to time. They can be used the same. But one of the other things that I found very useful about science and math simulations is specifically in math. It's a fantastic way for students to practice concepts that they've learned in class uh, in a setting outside of class. So, for instance, let's say your students, you work with them and they realize, well, they really need some help with fractions. They don't have a conceptual understanding of what a fraction is. There are lots of really great simulations that are designed specifically for that, specifically for kind of making the abstract concrete, which we'll talk more about later. So the simulations are fantastic in a lot of ways. But that's just kind of the running definition. But let's get into actually like how these improve learning. So I'm going to talk about something called the 5 E's quite a bit, which is a science and math. It's a kind of, if you've never explored it before, it is a really great way to teach both of those subjects. But it starts with, the first E is engage, and the second E is explore. So I'm going to talk a little bit about that kind of as we go through here in a few minutes. But I just want to kind of get it out there now so that if I talk about 5E's, it's not a new thing. So the first one is working with models can help students get a deeper understanding of concepts and skills. And this, again, falls into that 5E's piece, because at the very beginning, after you've engaged students with some sort of, in science anyway, it's like an anchor phenomena, then you go to give students time to explore what could have possibly caused that phenomena. A simulation is a fantastic way to do that, because as you change things, the model will change, or the simulation will change, the outcomes, the data will change as you manipulate pieces inside of it. So it really gives students an opportunity to understand something at a conceptual level before they even really start to learn about it. They're already building the background knowledge that they're going to need to really have a good understanding of it. Same with math. Math is, again, if you're teaching Pythagorean theorem, it's easy to kind of memorize the a squared plus b squared equals c squared piece, but an understanding of actual proof of the Pythagorean to show why it's set up the way it is, how come it's the equation works every single time with the right triangle. There are lots of simulations that will help students kind of bring that understanding of not just memorizing the piece of it, but why is it that way. So back to, and the next one is predicting outcomes when the variable changes. This is so huge in science. Being able to take things that you may not practically be able to do in your classroom. One of my favorites is germination, right? Like, if you wanted to change all the different variables that have to do with germination, the amount of water, the amount of light, the heat, the amount of heat that the seeds are exposed to, like the soil temperature, just those three variables by themselves can have so many different versions, right? Like, you could start with full light and 50 milliliters of water at 96 degrees. And then you can change all these things. To do that physically in your classroom would take months. It would just take forever. There are simulations that will do that for you, that take all that information, they run it through the little algorithms, and it gives you data in minutes rather than months. So being able to use that to then predict and perhaps even as evidence to support a claim is a really great use of simulations. And then there's the practice and extend concepts and skills, right? So to be able to take something that you've learned, kind of you got a basic understanding of, is great. But this allows opportunities to practice those skills in more of a concrete way. But the other nice thing, and this kind of fits into that RTI idea, is RTI isn't just for struggling students, right? It's not for picking up missed concepts. The other part of it is extending concepts further than what you would originally start, what your standard might say that you have to do. So, simulations are a fantastic way of doing that, of not just like practicing the skill so you get the skill, or even conceptualizing the skill, conceptualizing something that's abstract. It's extension. How do you extend this skill or this learning past this? The simulation is a great way to do it. And then lastly, understanding and refining their own thought process, like students' thought processes. One of the nice things about this is that it gives students an opportunity to be a little more iterative, to kind of fail at something, to perhaps not achieve their goal in their first try, and that they need to keep working on it. And this is a great opportunity for students to reflect and think about what they did, how they adjusted, and what they're going to do next. So how can we integrate this? Well, as I said before, student exploration, right? We're talking about students exploring a concept before they even learn about it, right? Just an opportunity to just explore fractions before you even understand what a fraction is. Just what is, like, let's look at it. Let's just play with this idea and see if students can start building their own ideas in their heads, and then you later come along and teach them whatever they need to know. Practicing a concept of skill, which I know we already mentioned, all right? The opportunity to practice those things. It applies student learning. If it's going to be, a simulation can take prior learning and use it to apply to something that's unique to them. Or they can take whatever you're doing in class that day, or that unit, or whatever it might be, and apply it to a new to a new situation for the assessment or whatever. Again, with RTI, right, it's not just about practicing weak skills, it's expanding on concepts for students who already got it. Working with variables, this is such a cool idea in a million ways. So there's like the idea of like an algebra balance, right? You can work with variables that way, or you can really get into what a variable is and understand that when you change one thing on this physics, simulation, you change one thing, it changes everything else. And that variable makes a difference as to what the outcomes are going to be. So not only are you working with gathering data, but you're really conceptualizing this idea of what a variable is and how it affects all the rest of the data sets that go around it. And then my last one is probably my favorite one. It's making abstract concepts concrete, right? There are so many things that are so abstract that we teach students, so many ideas that we can't conceptualize with, like, we can't just create on a table, right? We can build models, right? Like you can take a cell and build a cell model. You can do all those things. But what's nice about a simulation is that you can interact with that and help to make those abstract concepts more concrete. Again, fractions are easy. You can manipulate them on the table. But every time you go to do that, you have to take it all away and start all over again. With a simulation, you just press refresh and it just clears it all out and you start all over from scratch. Or whatever you're doing, it doesn't really matter. It's a great way to kind of really begin or really help students take those abstract ideas and make them more concrete. So let's look at some resources. We're going to look at each one of these pages here. So the first one is PhET. So this is PhET. If you've never used PhET before, it is really quite amazing. It's straight up simulations. And so we'll go to the website first. We'll start here. When you start, you go over to simulations and you can break them out by the different kind of the big ideas of science and also math. Click on whatever one works best for you. When you click on that, it'll bring you to this, to a kind of a landing page where you can work with the physics, the chemistry, right? They're all here, math concepts, but you can also adjust the grade levels to whatever you need it to be, whatever access you might need for different students, and whether it works with your device or not. PhET has done a really great job of turning all of their old Java stuff into HTML5 so that it will work on an iPad or any computer that you might have. So this is really great. PhET is always something that is always a go-to for me because there's some really great stuff to it. Let's just pick. So I'm going to kind of dive a little bit deeper here, just real quick. So we'll do middle school, and we'll do fractions intro. So here's the intro right there, right? It's easy to, it works better if you have an account set up for you, but all you need to do to share with students is just send them the link. There's different resources, again, so you have to sign in. There's the aligned documents right here, sims that might be related to it. There's activities that go along with this that are just, you just click them and it brings you to the activity and describes it for you. Translations are here, so you can change it to different languages, and then the credits are the credits. So I really like PhET. PhET is really great. Again, it's standards here. It's a really great simulation. There's lots of really great stuff about it, and all you have to do is just send them the link, and it will send students the link through whatever learning management system you use, like Google Classroom or whatever, and they'll click on it and it will go automatically to where it begins. But as you can see, here, I'll click this one real quick. There's the intro, there's the game, there's the lab. So when you click on the intro, it kind of helps you out a little bit to figure out, okay, 2, 1. All right, so I'm going to drag this up here. Right now I've got 1/1. Maybe I need 2, so maybe I'll take this, but I know I'm not right, so I'm going to bring this down, eliminate it. And if I make a mistake, I can just hit clear and it'll start all over again. And there it is. Oop, now I get a half. Right? I can play with this idea. So this might be one of those that you do as a class to help conceptualize the idea of a fraction. So you can change the different simulations, or you can give kids this and be like, okay, fill all these in. Oh, look, that's a piece there. Oh, you have 8 to go from that. So you can do it with bars, cylinders, a birthday cake, or a number line. So this one's really great. I really like this one a lot. Next one is the Concord Consortium, which is a math and science simulations. They're a little bit older. These are definitely for, they have elementary and middle, but it's mostly high school stuff. Again, breaks down by the different subjects inside of science. There's math and then there's engineering. These are really, really fantastic. So let's do a middle school one real quick. We'll do middle school chemistry. All right, so you got a particle view of gas. You click it, it'll bring you to the page that has some descriptions for you. So there's the requirements to run it, the idea of what it is. You do have to sign in to make this, it'll give you more information if you're all signed in. Kind of the basics idea, you can assign or share it, or print this page off. It doesn't have the connections to the Common Core or the Next Gen in here anywhere. It just focuses on subject areas. But it is a really great resource. I absolutely recommend it. It's super fantastic. And it's free. PhET and Concord Consortium, both free. The next one, Gizmos, is not free. And it is actually very, very, very expensive. But it is by far the best library of simulations that exists on the internet. Like it is so amazing what's on here. It's really fantastic. So I'm going to log in real quick. And we're going to go back here. So when you do this, you go to Find Gizmos. And you can, what I like about this is that you can look at it by standard, by grade, or by topic, or by textbook. If you have a textbook, there's, let's say you're using, I don't know, I've never checked the WIA before. You have all these books. You can click them, and it will automatically give you the simulations that fit with that section of the book. Really fantastic way to go about this. But I'm going to do standards, and again, you have the Common Core state standards. You have and then you can choose where you want to go from there. You can do by the Next Gen standards, and again, you can go by middle school. And here's all the simulations that fit underneath those standards. So Let's do, I'll do this one real quick. Go to lesson info. You do have to have an account. It does cost money. You assign students the Gizmo, and they go in with their student account and they log into it. But while as a teacher version of this, so here's the kind of the layout for this. Here's the Gizmo. We'll click on that in a few minutes. The materials, you have student exploration sheets in PDF and Word and Google Docs, which is really fantastic. What I love about a Google Doc, we'll click this one real quick. It gives you all the information. You can just give this to students. They can follow the directions as they go. You see right here, there it is. This is vocabulary, right? The prior knowledge stuff. So if you're working on this though, because it's a Google Doc, you can delete things that you don't want to have. So like if it just gives you the basics, that's what you want to do for your class that meets the expectations, and you don't want the last part, then you just delete it. Boom, it's gone. You don't need it anymore. And then you share this with students and they can fill it in as they go. So there's, and it's very user-friendly. I've had students use this before in the past. They do really great with it. The directions are very clear. And then you can have students pass in their work when they're done, however you want them to do it. There's the answer key for us, for the teachers right there. There's teacher's guides right here, if you need that, and a vocabulary sheet. There's also lessons submitted from the community, things that they've done in the past that might be useful for you to kind of pull off of. You can share it, which we'll get to in a minute, and then keep these things here. The other thing about this that's really nice is it comes with its own assessment, which is at the end of the Gizmo. So when you click on the Gizmo, it'll be right here, and then the students will play with that, do what they're doing, and then underneath is the quiz. And if this quiz works for your expectations, for what you want, then you can have that be there. And it will share you the information from the quiz with the students and with the teacher after you're done. But then you can see you just kind of drop stuff in, right? Add whatever you need to add, right? So add the thermometer. We'll add this. We'll pour that in. I don't know if you can, how do you get that in there? We'll play it. You'll put it in. It'll drop. It'll sizzle, right? And then it gives you the information down here below. There's a tools piece here, so you can screenshot, add for help, get arrows, add sound, whatever you might need. And then from here, you can have students do whatever you want them to do with this. So if they're going to use that doc, that Google Doc that you set up, then they're going to test with this and they're going to put their data in there. If they're not, then you build their own table and they want them to fill in the data. That's great. You can use the little screenshot tool here to take a picture of everything, so you have that as evidence. You can change the reactants, right? In this one, there's all sorts of things you can do with that. Because to be honest, like, I've done sodium and water in my class before. We've looked at all of this. We've looked at pH. We've looked at thermometer. We've looked at all stuff. But I've never had the time to do peroxide or silver nitrate, because I'm not going to get any silver nitrate. Ammonium nitrate I could do. Calcium chloride we could do. Either one of those would be fine. But this is great because it's all set up. And then you can change your different reactants as well. So it's really, really great. It's a fantastic website. It is very expensive though, but it is worth every single penny. I swear. I love Gizmos so much, and they're not paying me to tell you that I love Gizmos. I just love Gizmos. I used it a lot during the pandemic. In fact, I used it every day during the pandemic. So the next one is Legends of Learning. This is a free website. It is it's kind of, most people think of this as a game website, which it absolutely is. It's a fantastic use of RTI. It is a great way of assigning students an opportunity to explore things, but it is a lot of gaming. But the nice thing about it is that it's gaming with a purpose, right? It's not like cool math games where there's maybe an idea behind there somewhere. This is very much a based on science and math standards. It's all there and useful for you to use. So this is our home where we are, right? You have different things here that you can kind of work with. Let's create an assignment. Let me see if I can browse real quick. Here we are. So you go to browse, and we've done some science ones. Let's do some math ones. You assign these to students. So you build an account, and then students enter your account. There's a game piece of this that they can do on their own. That's great for RTI. You set them at their grade level and let them go, and it'll continually ask them questions. It's a battle game. So like one person, their student on one side, and then like a boss on the other side, and they have to they throw ice and stuff at each other. But in order to be able to power up, you have to answer the questions correctly. So let's do, we'll do problems surface area here. So that gives you kind of an instructional game to start with that you can absolutely use. And then the quizzes or instructional pieces below it that also fit that topic. When you're ready, you want to try it out beforehand to make sure that it's going to work for you. You can hit try game, and eventually it will load. There it goes. Right, and you just hit start, and then it gives you the directions. We don't need any sound. So really great. Kids love these things. It's a game, but it's run simulation. You choose to change different pieces of this, and then it gives you different outcomes. It's also fantastic, like I said, for RTI. Also really great for kind of reviewing whatever concepts you need to review beforehand. It is really it's really fun, and kids always engage these for students. The next one is Java Lab. For that one to load. Java Lab is math focused. I'm going to say that, and it's not going to load. Oh, there it goes. It is definitely higher level math, but you can get down here. There's a Pythagorean theorem one that I was talking about earlier. There's all math simulations. You have all these different pieces here too that you can do that are all simulations, the science and the maths. There's some really great stuff, definitely for older kids. No really any elementary stuff here. Bummer is you can't really look at the, we'll do normal distribution real quick. This is a middle school one. There really isn't a search, and it kind of gives you the basics here of how it would work, and then there's the simulation at the top. Doesn't really connect to standards. This really kind of more of a good exploration idea, but it is important to remember that there really isn't any work that's pre-made that goes with this. You'd have to kind of build your own information. You have to build your own kind of worksheet, if you will, or data sheet for students to keep track of. The National Library of Virtual Manipulatives is good. It is. I don't particularly like it myself. It is good. It is a good list of resources for all sorts of different things. But a lot of this is done in Java, and they didn't switch it to HTML5, so you have to have this app to be able to work with them. It's kind of a pain in the neck, but this is always the go-to, right? This has been around forever for all of us that taught math. Like this has been around since the beginning of technology in classrooms. They're tried and true. They're really great. They're K-12. They're all fantastic. But again, there's that access issue that's kind of a pain in the neck. And then there's NCTM Illuminations, which I don't know why that's still not linked, but I will absolutely link it. I didn't know this existed until I happened to be on it. But if you go, oh, here it is. Here's one. We'll go back in a minute. But you have, this activity where you have a pan balance, and you're balancing you're balancing the equations from one side to the other. This is the old kind of standard. Look at a 3 plus x equals 10 and balance them out so that they're equal. Really great. Standards are down here. Exploration piece at the bottom. Instructions are there. Pretty user friendly. Very good to use. It is right here. So when you go to the page, here it is. You can search by NCTM standards or by Common Core. You can search by grade level and by strand of your math. So really great. Not a lot to them. There's not a lot of choices, but the ones that they have are really well done and really engaging. And then the last one is called SimBucket, which is through PBS. Again, not a lot to choose from here, but some really good. What they do have is really well done. This is the SimBucket. These are the science ones. It is just science. There's no math, but there's some really good kind of choices here. It gives you grade levels underneath. We'll do the water one, and it gives you the standards here. If you want to look at the standards, it gives you about, right? The standards are there. That's really all there is to it. There's not a lot to, not a lot of pre-made kind of worksheety data collection type stuff. So you'd have to work at it from the kind of your own perspective, which is fine with me. I always appreciated that. So honestly, like I want to build my lesson around this, and I can set my my goals and my data sheets however I want. So that's SimBucket. That's the last one, and that's it for me. So I'm happy to dive in deeper with any of these if you're interested. Email me anytime, eric.wade@maine.gov. and I'll be happy to kind of work with you. You can follow me on Twitter. And if you click here, you'll take you to a quick little quiz. It'll just ask you some real basic questions. And then the answer in the thank you section, when you're done, we'll give you the link to go to here. You just put your name in there, submit and print, and you can add 1 hour of contact time. So thank you very much. Have a great day.